Today, very much more realistic type of financial situation. What we did the past 2 days was put a big lump sum of money away and let it sit there for a long, long time to earn interest. That does happen in the real world, but this is way more often. It is called an annuity. And the moral of the story of this is they put a certain amount of money away so often. Example, like we put $50 a month away, $50 a month away and save it. We put $1,000 away a year, every year, right? We're going to put more and more money into it, little by little by little, instead of saying, let's put $25,000 in an account and let it sit there. Most people are like, I don't have $25,000 to let sit there. Do you know what I'm saying? They put a little bit away, and as you grow older, I'll bet the place where you get your career will do that for you automatically. Like I have money taken straight out of my paycheck putting into funds for retirement and stuff like that. So that's called an annuity. What a formula! Woo! Here's what every bit of those things mean. What's weird about it is they changed some of the letters than what we're used to. S is the future value. That used to be A in the other formula. But the weird one for a lot of people is the principal, which is not really a principal. Instead of it being a P, it's called an R. This is the amount they invest each period. I think the reason why they changed it to an R is because principal is like a one-time deal. It's like we just put it away once. This is the same amount of money we're going to put over and over and over again. I is tricky. N is tricky. We're just going to dive in and kind of follow into this situation. So homework will go like this. You have to find 3 things first, your R, your I, and your N. Let's do that together. I'll bet by the 4th one, you'll feel pretty comfortable with this. So Yolanda deposits $500 away per quarter. There's how you know this is an annuity right there, because she's going to put money, $500 away more than once, right? She's going to do it per quarter into an account that pays, 8% per year. How do you feel about 8%? Good, bad, ugly, or awesome? That's pretty good, right? You know, per year. So don't let this trick you, right? This per year. That's the trickiest part about it. The magic word is quarterly. Cool? So here we go. Together, R is how much they're putting away every time. How do you feel about that being 500? Right? She's putting $500 away every time. Right? Here's the tricky part of I. I, we have to do a little setup. You'll probably want scratch paper for it when we do homework. Is we take the percent that they gave us. You feel about 0.08. Are we cool with that? But you have to divide it by however many times you're putting the money away. And in this case, they say quarterly. Are you with me on that? So what number will we put under there? A 4. Are we good with that? Then we're going to use our calculator to figure that out. Sorry, I didn't have my calculator open. Please divide 0.08 divided by 4. And the weirdest part is we'll never round that number off. If it comes out to be a long decimal, we're going to use the long decimal. So 0.08 divided by 4. How do you feel about 0.02? That's our I value. Again, this is kind of weird at first. We just got to dive in and swim to get used to this situation. And then N is the number of total periods. I have it written right here how you find it. This is how you find N in the chart. Years times compounding periods. How many years is she going to do it? Well, we have to look into the question. How much is in the account after 5 years? So how do you feel about 5 being the years right there? Times number of like compounding period. That's like the word quarterly. So what number would I multiply it by right there? 4. And multiply those together, and let's rock this. What's 5 times 4, baby? 20. I would like to explain that. That's a big part. She's going to put $500 away 4 times a year. Are you with me on that? Like per quarter. So 500 like in the first quarter, 500 in the second quarter, 500 in the third quarter, and 500 in the fourth quarter. Didn't she put like 500 away 4 times a year? If she did that for 5 years, would you believe she has done it 20 times? Are you with me on that? So in the first year, she put it away 4 times. In the second year, 4 more times, 4 more. So she's done it 20 times. Cool? So now let's use this complicated, weird old little formula. We got to kind of write it down. Our S is going to equal 500. That's our R value. And then we'll set it up with parentheses. There's this big old fraction in here. So I kind of started with a big old fraction bar. Check this out. I think we are all smart enough to do this. Right here it says 1 plus I inside the parentheses, right? What's I? We got him figured out. Right here, isn't it 0.02 right there? So if I add 1 to that, how do you feel about me just going straight to calling that 1.02, right? It's like 1 plus I goes in that spot. It's raised to the nth power. Cool thing is, we got n figured out right here. Isn't n 20? So we're going to raise that to the 20th. And then according to this formula, there is a minus 1 after that. So that's a minus 1. And here's the trickiest part. We got to divide it all by I. Be careful. It's not 1 plus I. It's just I. Isn't I 0.02? For the first example, are you kind of okay with where I got these numbers and what I'm doing? How to punch it in? I've been struggling with how to show you how to punch it in because there's a lot of ways to punch it in. Here's what I feel will be our way. Could you punch with me because it's kind of complicated. I'm going to give it a shot to punch it all in from, bless you, from left to right. But it's a parenthesis nightmare, right? So are you kind of with me on the parenthesis thing? So do you see how it says 500? I'm going to start with 500. And then here's the real trick. The real trick is parenthesis, parenthesis, right? Just trust me on that. We need parenthesis, parenthesis. Then it's 1.02 raised to the 20th. And then I got to get out of my exponent. Like your calculator might get you down already, but I got to go to the right a little bit to get out of my exponent. Minus 1. Are you cool with that? That's where we want to close the parenthesis off right there. So close the first parenthesis off, and there is a divide by 0.02 after that. We will then close that parenthesis. So it's sort of a weird double parenthesis nightmare because I needed to like make sure this numerator right here was all in parentheses by itself. So it should be a pretty decent amount, right? It should be a pretty decent amount. Did you get that number back in this case? We'll go to 2 decimal places, 68 cents or 69 cents. What would that round to? 68. $12,148.68. And again, I know the first one's a little weird. By the last one, we'll be way more comfortable with it. But here's where I find the interesting part. 5 years later, Yolanda's account's going to have the 12 grand in it. How much of that was her money? How much money did she put away every quarter? 500. How many times did she do it? 20 times. So what we do right here is we're going to take 500 times 20. She put $500 away every quarter 20 times. How did I get 20 times? Right there, the N, right? You know. So if we punch that in, 500 times 20. How much money did Yolanda actually put into this account? $10,000, right? So $10,000. Because she did $500 the first quarter, $500 the next quarter, $500 the next quarter after that. She did that 20 different times. She put $500 away. So she put in 10,000 bucks. The account has $12,148.68. How do I figure out how much interest she had? Guess what you do with those two numbers? You subtract them, baby. Subtract them. So I will do 12,148.68 minus 10,000. And how much money did she make? $2,148.68. That is not that much money. She didn't really make that much money. Why not? Interest rate was really good. What was not really good for her? Time. It's just 5 years, man. 5 years is not a long time in an investment strategy. So it's not that big of a deal. Yeah, she made $2 grand out of the deal, but that's not that big of a scenario. So let's try another one. That was weird. Carl is going to do this. He's going to deposit $200 per month. So there's our R, 200, into an account that pays 6% per year. That's pretty good. You know, over 5% is pretty good, right? So 6% per year, compounded how often? Monthly. So to figure out I, You got to take the 0.06, the percent that they gave you, divided by your, like, how many times a year you're doing it. In this case, it's monthly. So what would we divide by? 12. And then let's calculate that. 0.06 divided by 12. Never rounding that guy off. That's a tiny little decimal, 0.0005. So we will use that guy. 0.005. Rock on? Let's see if we can figure out n next. N is right here. You know, just like look up to your little chart that I made for you. It's how many years you're putting it in there for times compounding periods. Where do you find years at? In the question, right? You got to go in the question. They're putting it in there for 20 years. That's nice, right? 20 years is a good chunk of time, and we got us a pretty good interest rate, so we should get some money out of this scenario. So we will do 20 years times, how many times a year are we putting this $200 away? How many times? 12 times, because we did it every month. So in January we put $200 away. In February we put $200 away. In March, etc. Right? Every month we put $200 into this thing. So punching those in, you get 240. After you have like spent the 20 years, you have done that 240 times. You put money into the bank every month for 20 years. You have done it 240 times. So let's set up our formula. S is going to equal R, which is 200, times big old fraction boy. If you wanted to put another parenthesis here to kind of show you how to type that in, that's totally fine with me. 1 plus I, so 1.005, raised to the 240th power, take away 1, close up that parenthesis, divided by the tricky number of just 0.005. Many typos happen that they want to divide by 1.005. It doesn't have the 1 with it the second time. So let's punch that dude in. If you're sharing a calculator, let the other person punch it every once in a while, see if they can punch it. So 200, parenthesis, parenthesis, 1.005 raised to the 240th. Get out of your exponent. Minus 1, close it up. Close it up after the minus 1, divided by 0.005. Close it up. And we should get a pretty good amount of money right here. $92,000, man, you know. $92,408.18. But the super terrific secret is, so Carl's got 92 grand in this account. How much of it was his money? He put $200 a month away. How many times? 240 times, right? So we will multiply this. If you want to put a little formula for a cheat right here, we're taking R times N. You know, that's how we do it. R is how much money you're putting away times N, which is 240. So that's 200 times 240. How much of that money was Carl's? 200 times 240. About 48 grand, right? You know, 48,000 bucks was his actual money. And he turned it into 92 grand by letting it be in this annuity. How do you find the interest? Subtract those two. Subtract those two. Subtract those two. So 92,408.18 minus 48,000. Woo! Carl made 44 grand doing nothing, right? All he was doing was putting 200 bucks a month away. He put 48,000 away, and 20 years later, he got an extra 44 grand out of that scenario, right? Just by putting it into some cool annuity. So 4,408.18 is what he had. So it's time that I'm going to give you a little turn loose right here. Let's see if we can do this. Suppose $1,000 is invested at the end of each year for 5 years in an account that pays 10% interest compounded annually. Find the future value of that annuity. See if you can figure out what R is. What is R? How much money are they putting it away every time? What do you think? 1,000 is correct. $1,000, right? The weirdest thing about this annuity is how often are they doing it? They didn't say quarterly. They didn't say monthly. They said how often? Annually. How many times a year is that? Just once, right? This just once. We're going to put $1,000 in this account like every December or something. You know what I mean? Like we're just doing it once. So to find I, you'll always take this percenty boy, change him to a decimal, and divide him by how many times you do it. It was just once, right? So it just turns into 0.10 again, right? So 0.10. Nice. Let's see if you can find the number of times this would happen. It's right here. If I could use a highlighter instead of a pen. It's right here. You have to know how many years it was times how many times a year you did it. So 5 years times 1 time a year. Wouldn't that be 5, right? You know, it's like if you only put money away once and you do it for 5 years, it has happened 5 times. Cool? See if you can set up the formula. Can you put all the numbers in the right place? So S equals 1,000, 1.10 to the 5th minus 1 all over 1.10. Parenthesis. So we'll punch it in. It's 1,000. Double parenthesis. Boom, boom. 1.10 raised to the 5th. Get out of the exponent. Minus 1. Close it up. Divided by 0.10. Close it up. And I got that. 610510. 610510. 6105 and 10 cents. How much of that was their money? I'll bet we can do that without a calculator. They put $1,000 a year away for 5 years. How much of that was their money? Not 500, but 5. 5 grand. Sorry, I misheard you. $5,000, right? $5,000. The way I figured that out, just for your notes again, is R times N. Whatever R is, times N, right? That's how you figure out how much was their money. And then the interest, you subtract 110510. Why didn't they make much money? Their interest rate was awesome, right? They got 10% interest. That is awesome. Why didn't they make much money? 5 years, not a lot of time. So I made one question up for you. You might even be older than 17. But the real question is, $50 a month. You might not be able to afford that, I get that. But is $50 a month a lot of money? Probably not, right? Probably not. You're going to put that into an account that gives you really nice interest, 7.5%. And how long are you going to do it? Whoo! How long are you going to do it for? 50 years. By the time you are 67, which is retirement age for a lot of people, 65 sometimes, many people work to 67. Do you think we are going to get a lot of money out of this scenario? Good interest, amazing time. What do you think? A lot of money? Yes. Let's figure out the ingredients. What's R? How much are we putting away every month? $50. $50. I, this crazy percent as a decimal, divided by however many times they say. Didn't they say? Monthly, right? So that would be 12. Punching this in, we're going to get a wacky decimal. 0.075 divided by 12. Don't round it off, right? We're going to put 0.00625. 0.00625. Don't round it off. How many times will it happen? Right here. Years. Tell me, how many years? 50 years. Times how many times we do it per year? It's either quarterly, monthly, annually, that kind of stuff. Isn't it 12 in that? That is 600. I would like to time out. I kind of didn't do it in this order just because I wanted you to learn the formula. I think it's faster if we do part B first. Can you figure out how much of that is your money, right? You did $50 a month for 600 months. Can you figure out how much money you put in there? $50 a month times 600 months. How much? $30,000, which does seem like a lot of money. Not $50 a month, you know, like $50 a month isn't that big of a deal. If you don't know what your cell phone bill is, I guarantee your cell phone bill is about $120 a month. You know, it's just like $50 a month ain't much, you know. So let's see how much money we get though. So we're going to go all the way back to part A and do the formula. 1.00625 to the 600th power. Woohoo! Minus 1 all over 0.00625. Get ready to rake in the cash, bro. $50, double parenthesis, 1.00625 to the 600th. Get out of the exponent, minus 1, close it up, divided by 0.00625. Always double checking you have the right amount of zeros when you're punching stuff in, because it gets a little feel. How much money, baby? Go from the decimal backwards and put a comma every 3 spots, right? From the decimal backwards. So is that 32,000 or 328,000? That's a big old 328,221.91. How much interest did you earn? That minus 30,000. That number minus 30,000. You made basically $300,000 all by just using one little annuity. Would you put up 30 grand to get 300 grand? Yes or no? I think that answer is yes. And you don't even have to have the $30,000 now. You just need to give me $50 every month. Yes?